All right, last but not least, station number 9. Okay, this is the same one that was on the test, but I switched around the questioning a little bit. So we have a lab test for detection of a certain disease, and it's talking about um, a positive result 5% of the time for people who don't. So this is a false positive. So 5% is a false positive. And then it gives a negative result, a false negative. So negative result to people that actually have the disease. Really, that's a 0.3%. So less than 1% of the time. Okay, you have to look at if there's a decimal with a percent, that's very small. Okay, large scale studies have shown, so they already know, they don't know who, but large scale studies have shown that, okay, this disease is occurring in 2% of our population. So we're trying to figure out how many people is this affecting? What percent is this affecting? Okay. So the tree diagram is basically, let's just talk about, this is not the testing, this is just who has the disease and no disease. Okay. And so I think it's 2%, so that's 0.02, and this is 0.98. Okay. And I'm going to do a different color. Okay. So when you're testing people, obviously you're testing some people with the disease and some people that don't, but you don't know who they are, but you just know large scale that 2% have it and 98% don't. So the problem is there's a little bit of errors with these. So when you're testing for the disease, it either can be positive or negative, right? Now, it says, okay, let's go up here. It gives a positive result 5% of the time for people who do not have the disease. So we're going to follow the do not have the disease. And 5% of the time, it gives them a positive result. So 5%, we need to make sure 5% is 0.05. There's some mistakes people are making with their decimals. Oh no. So 5% of the time, they're giving it a wrong, like you don't have the disease, but scared because your test says you do. Okay. So, but 95% of the time, it's accurate in telling you, guess what? You don't have the disease, and your test, and the test is also showing that. Okay. Now, if you have the disease, it looks like it's pretty accurate in showing that. It's way less, there's less error up here. Okay. The test gives a negative result 0.3% of the time for people who actually have the disease. So people who have actually get the disease, a very small percent, 0.3%, right? 0.3% is 0.003, right? Okay, 3 out of every 1,000 people. Okay. So people that have the disease who will actually take a test and say, do I have it? They don't know, but that's why they're taking the test. It gives them a false negative. But it's accurate for 99.7 of them that have it. Okay. So now that's the tree diagram that you need to set up. And so there were some mistakes with this percentage because people didn't recognize that it was a decimal of a percent, less than 1. Okay. So what is the probability that a person randomly selected would test negative? So we're going to follow the branches to negative. Okay. So obviously a lot of people that don't have the disease, 95% of the people that don't have the disease are going to test negative. So that's this branch. Okay. So you're going to go, all of these people test negative, 0.98, 98% of the population, and then 95% of them. Okay. So that's 0.98 times 0.95. That's 0.931. Okay. Now, there's also some of these, a very small percentage of people with the disease are testing negative. So there's a very small percentage of people with the disease, and even really small percentage of them are showing up as negative. Okay. So we would go, this is the branch we're following because these people are also showing up as negative. So we're doing 0.02 times 0.003. These are all the people that are showing up negative. You can't just say these, because not all the people, not all the 98% of the people without the disease are showing up negative, right? We're getting kind of a lot of false positives. 5% is not that small when you're talking about getting results to say you have a disease that you don't. Okay, 0.02 times 0.003. Okay, it's like 4 zeros. 0.006. Okay, so now this is a probability that a person selected at random would test negative. What's the probability that you're going to test negative? Let's say test negative. Oh, sorry. So you're going to add those two together. So 0.00006 plus 0.931. You add those up. Okay. So this is all the people that test negative. So here it says, what is the probability that a person selected at random who tests negative for the disease actually has the disease? I didn't give the hint like I did on the test. It's saying, what's the probability that a person, given they've tested negative, actually has the disease? Okay. What's the probability that they test negative given they act? Nope, I said that wrong. Sorry. What's the probability that they have the disease given they have tested negative? Okay. Well, this is our denominator. All the people that tested negative, you need to total that up. We got that right there, right? So that's your denominator. What's the probability out of those, the people that have the disease, out of these, not going back to the beginning, out of these, how many people have the disease? Okay, people that have the disease that have tested negative. So have the disease, have tested negative. So that's this really small number. So it's really not that much, 1.93106. Okay, it is. Let me make sure I've got it right. I have 0.0006444. So it's a 0.00644% chance that somebody actually had, given that they tested negative, they actually have the disease. Lots of decimals there.